have a question for you. What kind of donut do you prefer? Yeast or cake? You might be wondering what this has to do with chemistry, but bear with me. Chemical reactions are happening around us all the time. Things you notice with your senses are because of chemistry and chemicals. Another word for chemical is matter. Everything is either energy or matter. Remember Einstein's famous equation, E equals mc squared? If it's not matter, it's energy. It's through experimenting with different types of matter and different amounts of energy that humans have been able to create some amazing things. Do you realize that when you're cooking and baking, you're actually doing chemistry? From creating fire for cooking to mixing ingredients together to make an amazing, chewy donut. Sorry, I got a little carried away. Where was I? Oh yes, humans have been experimenting with different chemical reactions for thousands of years, and it's shaped our lives and our cultures. In a chemical reaction, something is happening to the substances we're mixing together to create new substances. A chemical reaction is a process in which one or more substances, the reactants, are converted to one or more different substances, the products. Remember, we can't create or destroy mass. During any chemical reaction, no particles are created or destroyed. The atoms are simply rearranged from the reactants to the products. But how can you tell that you have made something new? Some common signs of a chemical reaction are the production of a gas, the production of a precipitate, a color change, a change in temperature, or production of light or sound. To truly understand whether we've created a new substance or not, we need to look at the reactions at a molecular level. In the kitchen, a lot of what we do depends on having heat. Heat can be created through a combustion reaction. Combustion, or burning, is a chemical reaction between a fuel and an oxidant accompanied by the production of heat in the form of flames. This is often how we cook our food. If you have a gas stove, the reaction would be methane combining with oxygen to produce carbon dioxide and water. Remember the conservation of mass? For every molecule of methane, 2 molecules of oxygen are used. The products are 2 molecules of water and 1 molecule of carbon dioxide when combustion is complete. This is an exothermic reaction. A lot of heat is generated when we burn fuel. That heat is used in other chemical reactions. A lot of CO2 is released as well, but that's the subject of another video. Speaking of CO2, this gas is very important when it comes to baking. Have you ever noticed that a great cake has nice, airy texture? The same goes for cake donuts. There's a lot of chemistry involved in getting the perfect cake texture. But fundamentally, we need a way to get gas bubbles into the batter. This can be done with baking soda or baking powder. Baking soda is a chemical called sodium bicarbonate. Baking soda will break down when heated, but only half of its CO2 is released, and another chemical, sodium carbonate, is formed. This sometimes gives baked goods that soapy or bitter taste if you add too much baking soda. When the sodium carbonate hits your stomach acid, the rest of the CO2 is released, and that can give you a gassy feeling. Baking soda is rarely used on its own, and is usually mixed with an acidic substance like buttermilk or cream of tartar to release its CO2. Even natural cocoa is acidic enough to create a reaction. Red velvet cake? Baking powder is basically a mixture of baking soda and a weak acid that combine when a liquid is added. Chemists figured out different types of acids could determine how much gas is produced, when it's produced, and for how long. Too much gas all at once, and you end up with a sunken cake. A fast rate of CO2 production is required for donuts, so the batter is aerated quickly and will float in the hot oil, ensuring a crisp outcome. Cakes take a little longer to bake, and all that gas, released quickly, can escape. We do have another way of getting bubbles into our baked goods. Yeast. If I were to eat one of these wonderful cake donuts, my body would eventually use the sugar to get energy. The process of getting energy from sugar is called cellular respiration. Yeast are tiny fungi cells that use glucose, fructose, sucrose, and starch for energy. Yeast also creates CO2, but this happens through a process called fermentation. When yeast ferments the sugars in the flour, the carbon dioxide can't escape because the dough is elastic and stretchy. The trapped gas causes the dough to inflate and rise. Using yeast to rise dough means the production of CO2 happens before baking. When chemists invented baking powder, it brought quick rising foods into homes. And because baking powder is activated by heat, the rising occurs in the oven, not on the countertop. This means the texture of yeast-risen baked goods is very different. Yeast donuts are light and chewy. Cake donuts are a little heavier, dunkable, and, well, cake-like. Food products from the fermentation of yeast have been consumed for thousands of years. We're great at finding natural chemical reactions and using them to our benefit. We're also great at discovering new chemical reactions to suit our needs. So may I ask you again, do you prefer yeast donuts or cake donuts? Whatever your preference, it's easy to marvel at the wonders of chemistry while eating your maple glazed, bacon-flavored donut, or your buttermilk old-fashioned, or even a red velvet cake. Bon appétit!